Now let's talk through the process of creating and assembling and running our very first assembly language program using our new assembler on the 16-bit CPU. We'll just do something very simple just to get us started. Now I write my assembly language in a text file, so I just use Notepad, but you can use whatever you would like. Now this is a notepad here. Now you're not going to necessarily understand all of the constructs that I put in here for the assembly language right at the beginning. I will describe these in a later video. But first of all, we're going to just take two numbers, put them in two registers, add them together and save the number in another register. So we have to tell the assembly language program, the assembler, where to find the start of our program. So the start of our program, we put in an assembler directive called origin. So origin 0 cross 8 1 2 3. So 0 cross means it's in hex. So we're finding the start of our program at position 8000, which is really the first position in our RAM. Now we'll put in just a couple of simple things to start off with. So the data command, we'll put a value of 5 into register R0, and again the data, we'll put a value of 3 into register R1. Okay, and remember, whenever you write these, it doesn't matter about spaces. Okay, here you could put these all together like this and it would still do it properly. Or if you want, you could leave a space here and you can leave out the comma and it would still work. But it won't work if you were to put this all together like that. Okay, it's going to get confused. Or if you were to take this and stick it together with the data, it will get confused. There has to be a space between these. Now, as I say, there doesn't have to be a comma here, but you can put it in if you want to. And finally, we're going to add. So we'll add R0, R1, and we've got the option to put the value into register. In fact, we don't have the option here. Whenever we do this, it will only save it into register R1. So we add R0 to R1 and it will save the value in R1. And then we can put in the end command. So that's all we're going to do, something really simple and straightforward. So we're going to have to save this. So we go File, Save, and for it to run properly, you're going to have to save it in the same folder that we have our assembler. Okay, so the assembler sits in here in the Python folder. Okay, so it's just sitting in here. Now you can save this as anything you want, so I'll just save this as, we'll put in add _1. Okay, so it's saved it as a text file. Now if we get into that folder, it's on my desktop and it's called Python. Now you'll note in that folder, it's a little bit small, but I've got a folder here that's called miscellaneous, which you can just ignore. We've got the assembler, which is assembler 500. Okay, we have the assembly language program we just generated, which is called add1. So this has to be in the same folder as this, otherwise it won't find it. Now another thing to note here is that if we had another text file in here and it was a copy of this or some other text file, then we don't want this to occur. We only ever want one text file to be sitting in this folder, and this is the text file which we will assemble. So make sure that if you've got any other text files here, that you either delete them or shift them into another folder here. For example, you could put it into some folder here. I've just called it miscellaneous. Okay, so the way the assembler works is it just looks for a text file in this folder, and it knows when it opens up that text file, that's the file you want to assemble. Now there's another folder here which you can generate, which is called machine code. So that's capital M and then machine underscore capital C code. Now this is going to hold the actual text out, the hexadecimal output. Now it's going to save, so whenever we run through the assembly language program, it will generate this file here called MC_H. So this is the file that we will be taking and loading into our CPU. So I can delete this for the moment, just so you can see it being generated. So now that we've done that, we can run up our Python. And of course you don't necessarily need to do it like this, but this is just one way of assembling the program. So we can run up Python, and I'm going to actually file open, and I'll open up the assembler. Python assembler, we can open it up here, and this is the assembler here. So we can actually just run this assembler. So whenever we click on the run, it will go to that folder that you've just seen. It will look for a text file and it will assemble that text file. So if I put run here, you see it's automatically gone in and ran that text, that assembled that text file. Now you don't need to bother with any of the stuff here. This might change. Okay, this was just outputs I was using in order for me to test my assembler. All that really matters is the line at the bottom. The line at the bottom is a copy of the output values from the assembler, and you can see here that is actually correct. The 0, 100 is the data command, and we're putting the value 5 into register R0. We're putting the value 3 into register R1. We're then doing the addition, and the answer will remain in that register R1. And then we've got the end command, which is 5800. So all of this will be saved to the file. So let's go and have a look and see now that we've assembled that, and we'll see what's happened. So you can see here now we've actually got another text file. So the other text file is called pass1. So this is pass1 of the assembler. Now you can leave this here because whenever we run up the assembler, it will just ignore the pass1 file. It won't try to open it, so you don't need to delete this. You can just leave this here. Okay. Now if we get in here, in this instance, it's not going to look any different than the add1, because it's not, well, other than the fact it's stripped off the origin, because the origin is an assembler directive. It's not actual part of the code whenever we run it up. So that's generated the first pass of the assembler. Now the second pass is the generation of the machine code. So if we click in this machine code folder, you'll see they've now got a folder called MC_H. So in effect, this is the second pass of the assembler. Okay, so that's the machine code, and it's in hex. And you can see it's really just that set of results we've seen at the bottom of the Python screen. So the data 5, data 3, the add, and then the end. So that's that available to us in MC_H. So we can then go ahead and we can load it into our CPU. So this is our CPU here. Make sure that we're on the reset, and of course, just to be double sure, the clock here should be sitting at 010. Okay, so that's the enable is high and the L and the S are low. So that's us at the starting position. Now if we get into the next layer down, okay, of course make sure it has been pressed reset. So we go to the next layer down and we get into the RAM. Now if we want to load the program up, we can just right click, edit contents, and we can open, and we can open up the file. So the file is in the Python folder under machine code, and this is the file here. So when we click on it here, it gives us this other option. Now we'll have to change this from binary to version 3 hex, so click on that, press OK, close the window, and that's us loaded the program in. So now we're in a position to run the program. So if you like, we could just go in here and go simulate, tick enabled, and it will run through it really quickly. Or we can get in here to the clock and we can clock it through. So if I clock this 4 times, that's 1 cycle on the clock. So you'll see this here changing. I'll go 1, 2, 3, 4. You see that's 1 cycle on the clock. Okay, so we can continue doing this, and you can see that we're going to go through the process of setting up the stack pointer. We're going to jump to the first location, which is 8000. We're then going to bring in the first command, which is the data command, into the instruction register, which is the 100. We're going to take the value there and put it in register R0. So there's a 5 going into register R0, goes to the next command, which is 101, which puts the value 3 in register R1. We then go through the addition 2501. Once we went through the addition, it's done 5 plus 3 gives us a value of 8, which is saved in register R1. We then go to the 5800, which is the end command, and the program ends. So that's our first assembly language program generated in the text file, and we've assembled it using our new Python assembler. We've loaded it into our CPU and we've ran it, and it works. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.